In this video, I'll take you through the procedure of creating what is known as a calculated type of question on Moodle. Okay, to understand what a calculated type of question is, let us look at this particular example. Okay, and here I'm assuming that you're already familiar with the idea of a question bank on Moodle and how to populate it with some basic questions. So let us look at this particular question. If the moment generating function mgf of a random variable x defined as whatever is given by e power s plus 8s square, okay, then the variance of x is whatever, right? So the point is that if this question happens to appear, right, it will appear in exactly this form in the final quiz as well, which means that if two students get the same question, they get the exact same answer as well. Okay, so the idea now is to use Moodle so that you can generate certain parameters in this question that will change the numerical answer every time this question is instantiated. So which means that even if the same conceptual question appears for two students, the numerical answers will be different, and hence they cannot just discuss and just use the answer. They still have to put in some effort to make some sort of a calculation. Okay, so with that brief introduction, let me tell you how you can create such questions. So to add a calculated type of question, you go to your question bank, right, and you select the category that you want, and let me say I have this category called Q1 and SEM, right, and I already have two questions, but I'll just tell you what the, how do you pick this type of question. So you say create new question, and then you say calculated simple, right, and then you create this question. As usual, you can give it a name, mgf1, and then you can start populating it with some details, but in the interest of time I will not populate this from scratch. I will just go ahead and edit my earlier question. Okay, so let me look at this particular question before I show you how they are created. I launched it the first time, and you see that it's the same question as we saw earlier, but this time it is e power 8.2s plus 4.6 s squared. Okay, that's the moment generating function, and I'm asking what the value of e power expected value of x square is. Right now I'll again create this particular question. Okay, and this time you see it is 5.1 s plus 6.1 s squared, right? So how does that happen? So it's the same question, but each time you instantiate it, it gets instantiated with a different set of numbers. Okay, so what I've done here is I've created my question as usual, in using LaTeX and other typical stuff, right? Consider a random variable, I should say x here actually, right? X whose moment generating function is given by e power, okay, notice this, there is this flower bracket m, okay, m into s, and there is flower bracket s, okay, that is different from this s, okay, that is the Laplace domain s square or whatever, and this s is actually a variable that is going to appear in my answer. Okay, these are the parameters that are going to get populated by Moodle automatically. Okay, so now let me look at the answer. Okay, the answer can be expressed in terms of these parameters. So the answer, for example, expectation of x square, right, is just m square plus that variable s into 2. Okay, and as usual I can create a relative tolerance plus minus, this is like 1%, right, plus minus 0.01 means 1% error, it can this thing, and of course the answer is there's only one correct answer, so this is 100%. Okay, so now you see that what are the wildcard values. Okay, so you see that first of all the wildcard parameters, right, if I click on find wildcards present in correct answer formula, right, it will say that there are two parameters m and s. Okay, and you have to enclose it in flower brackets, by the way. Okay, that's a necessity there. okay, and so I am saying the mean, for example, is from 1 to 10, right, and the standard, the value of S is also from 1 to 10. I could, set it according to my wish. And here I can, for example, I can generate about 10 random values, okay, and then I can also display 10 of them. So you see what has happened here. It will tell you automatically Moodle has auto generated 10 such values, okay. So each time the question is instantiated, one of these random values will be given to the value of M and S, right, from this set of 10, right. Now if you have a class of 100, then you can make 100 such sets, okay. So the key point is a single question which was like, going to go to n students, in exactly the same form, is now becoming a unique question for each student, and of course the answer can be evaluated each time differently according to this particular formula that I have given here, okay. So I go ahead and save changes, and yeah, so now you create this and you'll get 5.3 plus 4.5, okay, then 2.4 and 2.4, okay, and 6.5, 6.6 and 6.5, and so on, okay. So these are rather simple expressions that have been done. I mean, it's just squaring and adding two numbers. So this is nothing great about it, right? The only thing I'd like to caution you here is to make sure you put this multiplication operation in between when you want to multiply, right? You have to put it in order to get the right answer, okay. However, it turns out that there are many more complex things that you can do with this kind of a calculated question, and for that purpose let me go to one of my courses and I'll tell you a typical question that I would like to set, okay, and I'll show you how this can be implemented in Moodle using a calculated question type, okay. So the NMOS transistor threshold voltage equation is given by this: VTH naught plus gamma times root of Vs minus Vb plus psi s minus root of psi s, okay. So this psi s, gamma, VTH naught, they are all technology parameters, or they are constants as far as we are concerned in this question here, okay. So let us look at how I would go about implementing this, right. So VTH is equal to VTH naught plus gamma into whatever, right. Now I am assuming, by the way, now that I have set these constants to some particular values. For example, VTH naught is 0.45, gamma is 0.5, and so on, okay. So all I have to do is handle this square root. How am I doing that? I am doing it like this. I am using this function called POW, which is a unique keyword in Moodle. POW of Vs minus Vb, right, in flower braces again, because that will appear as a parameter in my question, plus 0.25. Psi s is equal to 0.25, and this comma 0.5 is square root. Pow of x comma 0.5 means square root, minus POV of 0.25 because psi s is 0.25 comma 0.5, right. So I can use this and essentially go ahead and set a question exactly like that, okay. So let me show you this question here, okay. So what I've done is I've given the parameter values, okay, that those equations that I'm talking about here, this VTH naught, gamma, and all that are actually given here as parameters in my question. You can see that VTN, right, instead of VTH naught, that is VTN equal to 0.45, and my gamma n is 0.5, okay. So I'm saying calculate the threshold voltage in volts of a long channel MOSFET with the following terminal voltages, right. This is just latex stuff. I want V underscore S to come, but this flower braces Vs is my Moodle calculated parameter. Similarly for Vb, right, and I am going to now set my answer as I showed you in my slide earlier as 0.45 plus 0.5 into POV of Vs minus Vb plus 0.25 comma 0.5 minus this POW of 0.25 comma 0.5 again, right? So as usual here, if I say find my wildcards, right, it will show me the wildcards, and of course there are two terminal voltages. Now these terminal voltages, of course I can't take whatever Moodle gives me, so I'm going to say it's between minus 0.1, minus 0.3 and plus 0.3, and I can give the number of decimal places, by the way, and here it's between minus 0.1 to 0.1. okay. So I say generate again, okay, and then I can do, in fact I can do, let's say 10 values, and I will say 10 values, and I will say display. Sorry, one second, I will say generate, yeah, and then display. Okay, so let me see what wildcard, yeah. So you see that there are 10 values, 10 sets where Vs is minus 0.2 and this is minus 0.1, and so on. Various values have been generated, and I can go ahead and save changes here. So now if I click on this question, right, you will see that the first time it gets generated as 0 and 0.2. okay, and of course now you can evaluate this equation exactly as per that equation that I showed here. You substitute these values and you will find that anything other than what satisfies that equation will be wrong. Okay, so this is actually quite good, but I'd like to show you that something even more non-trivial can be done. Okay, for that let me now proceed to the current equation of an NMOS transistor. Okay, so let's look at this equation. This clearly looks more intimidating and more complex. The current is 0 if a terminal voltage is less than a technology parameter. Okay, that 0.45 that I showed you earlier, right? VTH was 0.45. If it is greater, then it's given by some expression which is determined by the min of 3 different values. Okay, what I'm showing you in red here are my parameters that I'm going to parameterize in my question on Moodle. Okay, so VGS and VDS will be my calculated values that Moodle is going to randomly generate, right? So what I'm now doing is I have Vmin equal to min of VDS comma VGS minus VTH and VDSAT. Okay, VTH and VDSAT are constant values that are coming from that I have provided in that question, if you remember earlier. So now there are two things that we need to handle. Okay, one is this if condition. Okay, if VGS is less than VTH, it has to be 0. If it is greater, then I need to do something else. Now even there are 3 different conditions, right? It's the min of 3 different values, and then the answer will be determined by this Vmin value. Okay, so let me show you how this can be done. Okay, the first thing is to handle the if condition. If VGS less than VTH, right, you convert it to a max operation. Okay, max again is a keyword that is available in Moodle. So I am going to simply convert this to max of 0 comma VGS minus VTH. Remember, VTH is a constant which I assigned as 0.45. Okay, so max of 0 comma VGS minus 0.45 divided by VGS minus 0.45. Okay, let's assume that Moodle does not choose VGS to be 0.45. That's the only case where this will fail. Okay, when it will become divided by 0 error and I have a problem, right? But in all other cases this expression will work. So if VGS is greater than 0.45, then clearly it is evident that this will be a positive number and the max will simply be VGS minus 0.45, and I'm dividing by VGS minus 0.45. So the answer is 1. But if VGS is less than 0.45, then the answer will be 0. The max will be 0 and I will get 0 for this term. So the key idea is to simply multiply this expression here, right, by this max operation. Okay, so if it is less than VTH, then automatically it gets multiplied by 0 and the answer will be 0. Otherwise it will turn out to be this particular expression. The second thing is to handle the min of three cases, you remember, min of VGS, VDS and all this, right? These three cases here. Now to handle that, I am going to use the nested min condition. Okay, so I'm going to write Vmin as min of VGS minus 0.45 comma min of VDS comma 0.7. VDSAT I'm assuming is 0.7 in this question, right? So with that, I'll show you, how this question was coded. Again, I go here and I look at, I as usual put a figure with, all the technology parameters or constants that are needed. Then I use my parameters here, calculated parameters, which are VGS and VDS. Okay, and also I'm using another parameter called W, by the way, which I forgot to highlight here. This W by L here, right? This W in the expression is also a parameter which I'm going to use in this question. Okay, and of course I have coded this expression very carefully. You must do it carefully because you will run into an error if the formatting is not correct. So note that this first thing is getting multiplied by that whole current equation, which is the if condition that I spoke about. Okay, and after that it's a regular, just like the previous question, you can go ahead and code this whole thing in there. Okay, so as usual I come here and I say find wildcards present in correct answer. Okay, and I expand this and it will say VGS is between 1 and 10. Well, no, I want it to be between 0 and the supply voltage. Okay, what is the supply voltage? It is 1.8 volt, VDD equal to 1.8 volt. So I'm going to say 1.8, right? Then I'm going to say W is now, typically it's useful to just give integers here. Okay, so I'm going to say between 4 and 40 and I will say 0 decimal points. VDS again is going to be between 0 and 1.8 volt, terminal voltage. That's quite a standard thing. Every time you create this calculated question, please generate one new set of values first. Okay, you have to generate before you can save it. Okay, generate one set and then you do display one set first, right? You see that it is all right. Okay, so for example, it is created VGS equal to 1.5. okay, and VDS is not exactly shown here, but I can now go and change this and as usual create maybe 10 values and display about 10 values. Okay, so I'll say generate, right, and I can also, it will also display the 10 values. Okay, so I go ahead and save it, and now every time you click on this question, you will see that VGS, VDS, okay, 1 volt, 1.7 volt, and W is 22 in this expression, right? So let me close this and I will open this again, right? Now VGS is 0.1 volt, VDS is 1 volt, and W is 35 volt, 35 lambda, right? Is a number 35 actually. Okay, so note that W is coming as integers, VGS and VDS are coming as decimal numbers. So this is an easy thing to check for us. Note that VGS is less than VTH, 0.45, right? So from this equation, it's very clear that if that's the case, the correct answer should be 0, right? So let me just go back to that, right? Let me just go back to that. Yeah, so if I say 10 microamps, for example, submit and finish, it will say wrong. I'll say start again, right, and then say 0. Answer is correct. Okay, so clearly it is able to handle even these complex functions. Okay, and let me just show you this Moodle calculated. If you just search, you'll get this link here, and there are a basic set of functions that you can use. These are the functions that are available in Moodle. Okay, so you can freely use all of this and code even more complex questions on Moodle with this calculated type of question. Okay, so with that I'd like to summarize that you can literally create a unique question for every single student in the class.